So today we're working on a 3-brush generator from a Rolls-Royce Springfield Phantom 1. So Springfield Phantom 1s were originally 6-volt positive ground, which is what this generator is. It is a 3-brush generator. So the third brush, or the smaller brush, which is on the underside here, is for regulating the strength of the field to control the output so it does not overcharge or undercharge the battery. And that third brush is adjustable. This plate moves. Not all 3-brush generators are adjustable, but the Springfield ones, all of them are. That are the Rolls-Royce manufactured ones. There were also generators that were on very early Springfield Phantom 1s made by Westinghouse, and sometimes they even end up with Dijon generators and even Motocraft on the very late ones. But most of them have the Rolls-Royce made one, and I think that the Rolls-Royce one is probably the better unit out of all of them. They used a lot of carryover from the 12-volt third brush generator on British Phantom 1s, even though it looks different because it has the cutout on here and it has this plate with the movable brush and the band that goes around it. If you took those things off and you looked at it, it would look a lot like the British unit. So there's a little bit of interchangeability, but not much. The windings, of course, are going to be a different value with the armature and the field coils. So don't think you're going to get away with much. But the housing and some of the other parts do have some interchangeability. So as I had shown on a servicing and working on a 2-brush generator in a previous video, the first thing you always do when you take your generator off is test it. Even though you may feel that it's not working because it's not charging on the car, you still want to test it because there could be a problem in the car. Could be a problem with the cutout, could be something wrong with the wiring, could be fuses. You just don't know. So when you get it on the bench, the first thing you do is you give it a test. So now okay, so in order to bench test this dynamo, you want to connect a jumper lead going from the F terminal, which is the one in the center, to the A terminal, which is this one. And then also on the A terminal, you want your negative going to your voltmeter. And then your positive, you want your positive lead to your voltmeter going to that. So then you can use your electric hand drill. Usually a corded drill is better, and you want that in reverse, and you use that to spin your dynamo. And you'll notice it's putting out 1.8 volts. So this generator does have an issue and needs to be taken apart and checked and gone through. But we always want to do our initial bench test just to be sure we don't have a problem with something in the wiring of the car or in the cutout or some other place. Also, it's a good idea to disconnect your cutout. Once you get things working and all again, then reconnect your cutout and then check its operation, because it will close when it is connected to the correct terminals. This one was replaced with a diode, so it was connected to these 2 terminals, whereas the original cutout, I believe, goes from field to here. What I like to do at this point is to remove the drive spider. It is a right-hand thread. I generally just very gently use wedges to pop this off. There's no real room to get a puller or anything in there like that, and that usually does the trick. So now we have the spider off. We need to get the woodruff key out. There, that's a good sign. Sometimes it's the little things that can be the buggers. So we got that. Now we're going to remove our test leads. And I'm just going to go right to removing the third brush arrangement. So I'll show how that rotates. A lot of people don't realize that that is adjustable. Now don't go crazy turning it up way high. It doesn't need to be. You just want to be able to keep the car going. I like to keep it somewhere around the 10-12 amps range. So now we have to disconnect the little wire going to that brush. And that is a 1/4 inch. Maybe 4 BA. Okay, that's what that looks like. Brushes don't look terribly bad. Now we can undo these connections. And we want to make sure not to mix these up, since that will affect the polarity. So we'll mark them. Since the colors are the same, since the wires are the same color. So we'll put blue there. And blue there. So these paint markers are really very useful to have, since the marks stay on. Sharpies are good too, but these tend to stay on a little better. So now we have the screws around the perimeter that need to come off, come out. And these are just like in the British generators, the special screws with the 60-degree angle heads. I believe they're solid nickel. I loosened some of these up before. That's why they're coming out nicely. I don't remember loosening that one though. It looks like some are missing, perhaps. Sloppy, sloppy. Yeah. Not good. So with those undone, we should be able to remove the armature along with the brush holder end. Somebody had put indexing marks here, but there's really no need to be, because you know this hole goes with that center stud. So it's feeling a little bit on the tighter side. So I think I'm going to remove the rear cover. We're going to replace the bearings anyway, but I'm going to remove that rear cover just to give me more options. I'll even break these loose too, since we're gonna replace that bearing. I believe I'll be able to leave the cutout on place with what we're doing, but I might take it off anyway because I would like to clean that rust off of this housing. Just for general principles. So once we get the armature out, we're going to use a growler to check the armature. If it checks out, then I'll resurface it, the commutator, and then we'll check the field coils, see how they are, and then replace the brushes and bed them in. And that should be able to produce a working unit. So it feels like that bearing is holding fairly tight. So we'll just gently give it a little persuasion. Give it the sniff test. Doesn't smell terribly burnt. I don't see any burns, so hopefully it's good. Field coils look okay. So let's get this armature off. The important thing when using a press is to not let it get away from you. also not to break anything. Still feeling pretty tight. There it goes. Very tight, Barry. It's a heavy bugger. So this is how you test the armature using a growler. So you place it on the growler as instructed, like that. You take a hacksaw blade and you slowly slide it along the segments. And you hope nothing happens. When something happens, it's going to be like this. If it's bad. And this one's showing good. In my other generator video, I showed a bad armature tested in by the growler. Now you can also check these segments. One probe goes to there, and you run the other probe around. And if you have a bad segment, you're going to get that. So all those test good as well. So now we're going to put our armature in the lathe and we're going to resurface the commutator. Okay, so we have our armature set up in the lathe. So I can get the best position here. That looks pretty good. And we're going to trim down the commutator. It's spinning nice and true. So we will proceed. Just started to skim, so we zero out our indicator over here, and we'll do about a 10,000ths cut. Which isn't doing much. We're going to need to do more than the 10. Do another 10. Total of 20. All right. Now we're starting to get into it a little bit better. And we're going to check. And I think we're there. So we had to take off a total of 20. Now you'll notice in some of the segments we have a little bit of carryover, and I'll clean that out. Usually I just use a knife. So we're in good shape there. Now I'm going to use some fine emery, and we're going to clean this surface. You want to use emery cloth, because you're not going to get any grit embedded into anything, and you don't want any grit embedded in anything. So I just like to give these areas a little cleaning up. They tend to get a little rusty. Emery is a material that was from Turkey. I don't know if it's some kind of mineral or what, but you want to stay away from these wraps over here, because then you can damage those. So I cleaned up very nicely. I suspect this armature's been rewound sometime. This looks a little more like a commercial rewinding than a Rolls-Royce winding. But whoever did it did do a nice job, and they put this extra band of reinforcement on here, and they shellacked it nicely, and then they put a nice bit of whipping around here to keep these segments from becoming unsoldered. And it tests fine, so we should be in good shape with this armature. So now we're going to get it out. We're going to clean up our parts, and we're going to bed our brushes. We're going to get new brushes and bed them, put it together, and give it a test. Okay, so now we are ready to bed our brushes. We have our emery stuck to the commutator. It's nice, well stuck on there. I used some 3M double-sided sticky tape. In the past, I have used hot glue gun. I think the sticky tape works a little better. There's really no big difference in time. But you know, you have that option as well. I don't have the bearings set in all the way because it's in enough that I'm going to be able to get a nice contour on the brushes. I did want to point out that the last person who was working on this generator, who's probably the last rebuilder, and I don't think it has a whole lot of hours on it since the rebuild, but anyway, they used Loctite to hold the bearings in. The bearings didn't feel terribly loose in there, so I don't know what the reasoning was for using the Loctite, but that's why I had some difficulty in taking it apart. Now, if that fellow was working in my shop and he did that, I would have told him, do not do that ever again, unless it's necessary. And if it is that the bearing is very loose, then we'll figure out a way to tighten it up. We might need to put a little knurl on the inside, or sleeve it, or do something to correct it properly, because Loctite works, and it works really well, but these castings are also very fragile, and trying to get things apart when they're Loctited together with these fragile castings and risk breaking them is very great. So we want to avoid that. So, you know, again, or I guess you could use a lower strength Loctite, and then maybe if you were the one who was taking it apart again, you would know, and you would apply some heat from a heat gun or something. But you know, a lot of these things aren't coming apart until who knows how many years later, or decades later. So anyway, we're going to proceed with bedding in our brushes. Now, I measured out the brushes that came out of it and compared it to some new ones, and there's hardly any wear on these whatsoever. So they're still in very good condition. So I'm going to reuse them again. So we get our brushes into place. Make sure that they're nice and free. If there's any stickiness from a high spot, then what you do is you put your emery down on a piece of plate glass or a surface table and take down that high spot. The dividers in these brush holders is a very thin brass, and a lot of times that brass will distort or pinch in. So we want to be sure that the brushes are up against the emery. So yeah, so this one feels tight. And I see a mark on there. Let me just try one of the other ones. See if it's any better. So you want to work it free. And now it feels nice. Again, it has to snap back on its own. And this is critical that they feel good and free in there. Also, the bedding is critical. Some rebuilders feel that allowing them to bed on their own without doing this will work fine. But for some reason, the Rolls-Royce and Bentley generators are too fussy for that. So we spin it around. Our brushes are rubbing up against the emery, and they're going to develop a contour that's going to be very, very close to the commutator, which is what we want. So we want as much contact between the brush and the commutator as possible. And I also find it's best to spin in one direction. If you go back and forth, it'll leave an odd bedding mark on the brushes. I can see the bottom ones look like they're bedding in nicely, and you look at the contour, and if it looks like you have marks going all the way across the contour, then that one's bed. So this one is. So I'm just going to leave it like that. We're going to check the next one. Okay, you see that one's not touching all the way, so we're going to put that one back in, and so it can go against the emery. Oops. Ooh, I gotta put the wrong brush in that one. Okay, so I'm going to be starting fresh with that one. We'll check this one now. And that one's nice in bed. So the two upper ones still need a little bit more time. Ooh. This one's hanging up on me. Whoa. What's going on here? And don't even see it coming through. Okay, so it looks like there's a little rub mark right there. So I'm going to give it a little bit of a surfacing. Brushes for generators are pure carbon. Brushes for starters are carbon and copper. And you do not want to use a carbon and copper brush on a generator. And now we have that one touching nicely. Oops. And that one too. So we'll give this some more spins. I can see the carbon building up on the emery. It's almost there. And that one is there. So we just have this one more to do. Sometimes you need to blow out some of this carbon. You don't really need much more than a couple of nuts. These are 2BA. And we do the same thing we did with the other ones. That one feels tight. So we see it's been rubbing there. So we're going to take that down a little bit. There, nice and free. These are a little smaller, so they'll bed in a little quicker, nice and free, like that. Spin this guy around. And we're going to check them out. Okay, that one's bad. And that one's bad as well. So now we can take this off, clean off our commutator because it's going to have some stickiness to it, and put the generator back together and give it a test. So we now have everything ready to go back together with our Springfield Phantom 1 generator. So I'm just doing a little check with the field coils. They're coming up as 1.3 ohms resistance. Also check that the circuit is not open, that everything is still insulated with all these connections. And they are. I also wanted to point out if that all checks out okay, you can do a visual check of the fuel coils, and you'll notice that they are beautifully wound and covered, and this is an Egyptian linen. If you read the manifest for the parts list, you can see how much of a length that they had to use. But just look at the quality of this. These are original fuel coil windings. They're in beautiful condition. They usually are with a generator because they were just so well done originally. So it's very, very difficult to find somebody who's going to make you fuel coils this nice again. So if you have ones that are nice, I suggest you keep with them. And I always think it's very much a shame because you have people who take these generators and they gut them out and they put alternators inside of them, and they think that 12 volts is better. And the bottom line is I don't really see that you have a huge improvement going to 12 volt, and you're certainly ruining some beautiful craftsmanship when you take all these guts out and throw them away and cram in there an alternator. And also I don't think it's a huge issue, but I do have concerns that if you put an alternator in a space like this and it doesn't have enough air circulation, that it could potentially overheat. So normally the outside of the shell is a nickel plating. I think a satin nickel plating is probably correct, although you do see some of them that are a bright nickel finish. So now you have the cover plate for the rear that holds the bearing. This bearing is a 6303, which is a pretty common bearing, and it is a sealed bearing. Normally it would have been an open bearing and it would have been lubricated from this Bijur fitting. Springfield Phantom ones are blessed to have a Bijur system. Normally there's a little copper tube that comes out of here. I guess it's just to let some of the excess oil to flow out. So now if you have a sealed bearing, you don't really need the Bijur system. So it's kind of debatable if you should just pop off the seals, keep it a sealed bearing, or how you want to handle it. So I would suspect any extra oil is just going to flow out and find its way out, but it is something to keep in mind. You'll notice that the part number starts with an A, meaning that this part is specific for Springfield cars. If it were a British generator part, then it would have started with, I believe, an E. But they started using the A's for Springfield specific parts. So now on the other end we have the third brush holding plate. Those are the slotted holes for the adjustment. Bijur connection. Part number, again starting with an A because it is a Springfield specific part. And the brush holder itself and the brushes are ready to go. You also want to verify that your springs are in good shape and that they're strong enough to return the brush up against the commutator. And then here we have the armature, which we have spoken a bit about. We have that back with the emery, and the tape has been removed and the stickiness has been cleaned off. The brushes are just hanging out in there, and the new bearing is in place there. This is also a standard bearing. I forget the number for it though. And again, I believe somebody has rewound this armature. It doesn't look quite like an original, but whoever did it did a very nice job. If I knew who did it, I would probably send armatures to them. But this was probably all done many, many years ago, and the business is probably gone. But it might be something to check into. So now I'm ready to slip it back together, give it a test, and see what it's going to do. You can really start with just about putting either end on, but I like to put the armature and this part of it on first. You want to be sure to run your leads carefully through this hole. And we have one at the bottom here. And that just comes through an opening. We have our wire marked blue going to the brush holder marked blue. This is where a lot of times people change the polarity of these by changing these two wires. Again, positive ground is fine. You can always use a 12-volt converter if you want to operate anything 12 volt from your electrical system. I normally just put 2 screws in each cover to start. If you put all the screws in, there's bound to be an issue and you have to take it apart and check something out. If you put 2 screws in, you're more likely to have better luck. Don't ask me why it's that way, but just how it is. So now is a good time to put on your rear cover plate. And just put 2 screws in on that end as well. That's fine for testing purposes. Somebody put some indexing marks here at one time. And now we connect the brush leads and the terminals. Okay, so now we're ready to test our generator. We have our jumper going back on jumping A to F, and our meter negative going to those terminals, and our meter positive going to the plus. We're going to spin it with the drill. Is going to actually be in reverse. You'll notice that we have about a 16.5 voltage output, and you can hear the loading on the drill, which you did not hear on our initial test when it wasn't working. But you can hear the work the drill is doing. Now you can adjust the output by moving the third brush. Now, even though the voltage went down, the loading on the drill went up. Whoops. And since the loading on the drill went up and the voltage went down, it turned the RPMs down of the drill. It's making the drill work harder, so it's not turning as fast. So that's why it's actually putting out less voltage. And then if we turn it this direction, it spins faster, easier on the drill. And a higher voltage. And somebody's also put a witness mark there, so they probably had it set right about in that position. And now I'll show you the RPMs. Remember last time it was about 700 with no load. Now with a load, it's about 100. At 16 volts. If we turn the charging back some so it doesn't charge as much. And it is now about, I would say 110 RPM. So that's the difference that the third brush movement makes. This is the whole way, and it takes it way down. So hopefully that gives you a demonstration. So like I say, turning the brush up puts more load. It strengthens the field. Strengthening the field makes it harder to turn. So that's why the drill is laboring more. And the drill, since it's laboring more, it can't spin the generator fast enough to put out the higher voltage. But the engine will. So hopefully that won't be confusing. But you'll notice that the output is right within the range of a healthy working generator. Now, unfortunately, somebody changed this cutout, probably because it failed with a diode. And I have noticed that this diode has failed because I was doing some testing, and it would actually cause the generator not to work. So I'm going to have to figure out something with another diode to use as a cutout, because I'm assuming this cutout is no good. I know it doesn't want to spring back, but I may just try to adjust it and see if I can get it to work again, because sometimes people do things like this and there's just a simple problem and they didn't want to deal with it, so they thought they were going to solve it using a modern piece of technology. So I had to fool with this a little bit more, but we now have a working generator. Didn't work before. It works now. It's all refreshened with a resurfaced commutator. The brushes are bed and in really good shape, and bearings are replaced. So this unit, once we figure out the cutout, is ready to go on and will perform for hopefully many years to come.